Welcome you all. I am Dr. Jagan, Associate Professor, Electronics and Communication Department from Rohini College of Engineering and Technology, Kanyakumari. So this video I have discussed about ADA wireless sensor networks.
Possible solution for jamming. Jamming in wireless network is defined as the disruption of the existing wireless communication by decreasing the signal to noise ratio at receiver sides through the transmission of interface in wireless signals. Jamming can be done at different levels from hindering transmission to distorting packets in legitimate communications. Jamming makes use of intentional radio interferences to harm wireless communication by keeping communicating medium busy, causing a transmitter to back off whenever it senses busy wireless medium or corrupted signal received at receivers. Jamming mostly targets attacks at the physical layer, but sometimes cross-layer attacks are possible too. Types of jammer. Jammers are malicious wireless nodes planted by an attacker to cause intentional interference in a wireless network. Depending upon the attack strategy, a jammer can either have the same or different capabilities from legitimate nodes in the network which they are attacking. The jamming effect of a jammer depends on its radio transmitter power, location, and influence on the network or the targeted node. A jammer may jam a network in various ways to make the jamming as effective as possible. Basically, a jammer can be either proactive and reactive. Proactive jammer transmits jamming interference signal whether or not there is data communication in a network. It sends packet or random bits on the channel it is operating on, putting all the other nodes on the channel in on operating modes. However, it does not switch channels and operates on only one channel until its energy is exhausted. There are three basic types of proactive jammers: constant, deceptive, and random. Constant jammer emits continuous random bits without following the CSMA protocol. A constant jammer prevents legitimate nodes from communicating with each other by causing the wireless media to be constantly busy. This type of attack is energy efficient and easy to detect, but is very easy to launch and can damage network communications. Deceptive jammer sends a constant stream of bytes into the network to make it look like legitimate traffic. Random jammer intermittently transmits either random bits or regular packets into networks. It continuously switches between two states, sleep phase and jamming phase. It sleeps for a certain time of period and then becomes active for jamming before returning back to a sleep state. Countermeasures for reactive jammer. Reactive jamming detection using PAR. It is used to detect jamming using the bit error rate. For reactive jammers that keep the received signal strength low while introducing disruption in a packet. By looking at the RSS of each bit during the reception, it identifies the cause of bit errors for individual packet using predetermined knowledge error correcting codes or wire node change systems. If the error is due to weak signal, the RSS should be low. If the received signal strength RSS value is high for a bit error, there are external interference or jamming. Assuming nodes can access the expected local interference, the sequential jamming probability test calculates the marginal likelihood of errors due to 10 unintentional collections. If this value is less than the log of the ratio of targeted probability for a missed alarm to the targeted probability, then there is jamming and an alarm is raised. If the marginal likelihood is less than the ratio, there is no jamming and the sequence is reset. There is also a possibility that no conclusion is made until there are some more conclusive evidence for jamming. Tampering attack and its countermeasures. An attacker can damage or replace sensor and computation hardware and the program codes or remove sensitive materials like cryptographic keys to allow unrestricted access to higher levels of communications. Therefore, These tampering nodes interfere in the physical access of sensor nodes. Countermeasures. Some attacks in the physical layer are quite hard to cope with. For example, after sensors are deployed in the field, it is difficult to infeasible to prevent every single sensor from device tampering. Therefore, although there are some mechanisms that attempt to reduce the occurrence of attacks, more of them focus on protecting information from divulgence. Obviously, restricting adversaries from physically accessing or getting close to sensor is effective. It is good to have such restrictions if we can, but unfortunately they are either difficult or infeasible in most cases. Therefore, we usually have to fall back on another type of restriction: communication media access restrictions. A few techniques exist nowadays that prevent attackers from accessing the wireless medium in use, including sleeping, hibernating, and spread spectrum communications. This technique uses either analog schemes where the frequency variation is continuous, or digital scheme, example frequency coping, where the frequency variation is abrupt. By this way, attackers cannot easily locate the communication channel and are thus restrained from attacking. The spread spectrum communications are not yet feasible for wireless sensor networks that are usually constrained in resources. Directional antenna is another technique for access restriction. By confining the direction of the signal propagation, it reduces the chances of adversaries accessing the communication channel. In general, cryptography is the all-purpose solution to achieve security goals in wireless sensor networks. To protect data confidentiality, cryptography is indispensable. Cryptography can be applied to data stored on sensors. Once data are encrypted, even if the sensor are captured, it is difficult for the adversaries to obtain useful information. A more costly encryption can yield higher strength, but it also trains the limited precious energy faster and needs phone memory. More often, cryptography is applied to the data in transmission. There are basically two categories of cryptographic mechanism: asymmetric and symmetric. In asymmetric mechanisms, RSA, the keys used for encryption and decryption are different, allowing for easier key distribution. It usually requires that trusted party called certificate authorities to distribute and check certificates so that the identity of the users using a certain key can be verified. However, due to the lack of prior trust relationship and infrastructure support, it is infeasible to have CAs in wireless sensor networks. Furthermore, asymmetric cryptography usually consumes more resources such as computation and memory. In comparison, symmetric mechanisms are more economical in terms of resource consumption. As long as two nodes share a key, they can use this key to encrypt and decrypt data and securely communicate with each other. Thank you.